Okay, so let's use what we know about reference angles to fill in our whole unit circle. All right, so I'm going to continue with orange on these. So we have in the left, we have a -1, 0 for our quadrant angle. And then in between those is quadrant 2 up here. This is quadrant 1. And by the way, this would be theta is less than 90, greater than 0. Or theta is less than pi over 2, greater than 0. Okay, and we have those filled out already. We're talking about the points now, which is our cosine and our sine. These are the values of the functions. Okay, so let's do we want to know how to do the whole unit circle. All right, so we know that at 30 degrees, we have radical 3 over 2, 1/2. Well, if we flip it this way, it's just going to be negative radical 3 over 2 because we need a negative cosine in quadrant 2 and a positive 1/2. So all the cosines will be negative, negative radical 2 over 2, and all the sines will be positive. And then pi over 3 flips over to 2 pi over 3. So instead of 1/2, it's negative 1/2 and a positive radical 3 over 2. Okay, and so because the reference angle for example, 2 pi over 3, the reference angle for 2 pi over 3 is pi over 3. They have the same sines and cosines, different sign. Positive or negative, whereas in quadrant 2, 2 pi over 3 has a negative cosine. All right, and then we have this. Okay, and then we actually can reflect these down and make this a little bit smaller. Maybe, there we go. So you can see that it's small, but you can see that the purple is going to be my pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And all those have the reference angle of pi over 6. And so we're going to be using the square root of 3 over 2 for the cosine or the x-coordinate and 1/2 for the y-coordinate. But we also need to put the correct signs. So here, let's go ahead and fill this in your unit circle. Right here, positive is sine and cosine, and negative is nothing. Here we have a positive sine, but a negative cosine. That's quadrant 2. So quadrant 3, we have nothing's positive. We have a negative sine and a negative cosine. So that means that the radical 2's, which are in the middle, radical 2 over 2, those are both negative. And then this pi over 6 is going to be the same two numbers as square root of 3 over 2 and 1/2, but they're both negative. And these guys are just those reversed. The 1/2 comes first and the square root of 3 over 2, but they're both negative. Okay, and then in quadrant 4, we have a positive cosine and a negative sine. And so I always put the radical 2 over 2's in the middle first. So the cosine is positive, but the sine is negative. And then I'll put this one is the square root of 3 over 2 and 1/2, and then 1/2 is negative, and this one is the 1/2, and the square root of 3 over 2 is negative. Okay, so let's see, we've got 1, 2, 3, 4, 5. So we have all of these, and this is 0, -1. Okay, now we have our unit circle pretty much complete. And what I'd like to do is go back to, there is on your handout, we want to be able to find some problems like this. Find a second angle with the same sine as 40 degrees and the same cosine as 40 degrees. And then find a second angle with the same sine as 200 degrees and the same cosine. These are things that you're going to be doing in your first mom or your second mom forum, where you choose your angle and respond to somebody who has the same as you. But first, here's an interactive reference angle tool that I have opened up, and I'd like to share that with you. And that is right here. Okay. So let's take it. This is mathopenref.com. Anyway, what I can do is drag this point, and you can see that the angle itself is 40 degrees and the reference angle is the same as the angle. Okay, and when I get up to 90, oh, now what happens is the angle is 115 degrees, but the reference angle is 65. And if I keep moving that, right here, the angle is 156, but the reference angle is 24. It's kind of cool to help you see what reference angles are. Now you can see here's a 45-degree reference angle, but the real angle is 225 degrees. And if I go all the way into the fourth quadrant, my real angle would be 300, let's get a nice one, 330 degrees, but the reference angle is only 30 degrees. Okay, so, and I would like it to be radians too. So I can change that to radians. Now let's go back. Oops, grab the point. Let's go up to right there. And I thought they did it in terms of pi. Anyway, you could play with this. I don't like this too much because it isn't in terms of pi, but you can actually see we're almost at 5.46 radians. Because remember, 6.28 is 2 pi radians all the way across that angle, but the reference angle is just the distance to the x-axis. Okay, so remember that right here is 180 degrees or 3.14 radians, which is pi. So if somebody says, hey, my angle is about 5 radians, you're going to be right about here. That's about 5 radians. And that's in the fourth quadrant. Okay, so anyway, this is just something I wanted to show you. It's kind of fun to play with. And let's go back to the questions. All right, so a second angle with the same sine as 40 degrees. Well, let's look at 40 degrees. 40 degrees is right here. Okay, now if I'm on the unit circle, the sine is going to be the y coordinate right there. And I don't know what it is. I'm not going to look because it's not one of my special angles. The special angles are 45, 30, and 60. But this is not a special angle, so I can use my calculator, which we'll do next. But first, I don't want the angle. I don't want the measure of the cosine or the sine. All I want is another angle with the same sign. So the same sign is the y coordinate. So I'm going to use my reference angles. Here's all 4 of them right here. And this is 40 degrees. These are all 40 degrees. So which one of those has the same sign? So this is positive, positive. So I need a positive sign, and that is in this quadrant. We're going to have a negative cosine and a positive sine. So whatever this angle is right here has the same sign as my 40 degrees. And that angle is going to be 180 back up 40. So the answer is 140 degrees. So another angle that has the same sign as 40 is 140. Now, which angle has the same cosine? That's this x coordinate. So this is a positive x coordinate. So I need this x coordinate right here because it's positive. And so this angle is 360, go back 40. So that's going to be 320 degrees. So the same cosine is 320 degrees as my 40 degrees. Okay, the same sine is they both go up the same amount on the y, and the same cosine is they both have the same x coordinate. All right, let's do that again with 200 degrees. I'm going to erase this so I have some room. Okay, so 240 degrees. I'm going to draw that first. So let's go. All I need to know is that this is 180 and this is 270. So 240 is going to be somewhere in here. 240 degrees. Now, my cosine is negative and my sine is also negative, remember? So I have a negative, cosine is negative and sine is negative. So if they say they want the same sine, then I need, remember here's my 4 angles. I need one with the same sign. So that's going to be this guy over here. It's going to also have a negative sign. So if this is my X, this is my Y, this is this X, this is a negative. So it's going to be 240 has a reference, or sorry, 200. I did this wrong, didn't I? I did 240. Sorry, I'm just going to do it right because it says 200 here and I did 240. So let me just change that to what it says, which is 200 degrees. So that's going to be a little bit closer up here. So my reference angle right here from 180 to 200 is 20 degrees. Now this angle, these are all 20 degrees now. So this angle, which is the one I really want, is going to be 360 minus 20. So it's going to be 340 degrees. Has the same sign. So that's going to be 340 degrees. Now the same cosine is the x coordinate. So this is a negative. Right here is my target. Okay, this has a negative cosine, but so does this one. This one has a negative cosine. So that's going to be 20 degrees up from 180 or 160 degrees. 160 degrees. Okay, so that's one skill we can do. You want to know your unit circle so that when you visualize the cosine of 120 degrees, you need to remember, okay, 120 degrees, here's 90, here's 180, 120 is going to be up here, 120, and that means the cosine is negative and the sign is positive, and that you want to memorize these. That's going to be negative 1/2, and this is the square root of 3 over 2. So the point is negative 1/2 square root of 3 over 2, and the answer would be, for the cosine of 120, would be negative 1/2. The sine of 3 pi over 4, okay, different color, 3 pi over 4, here's 1 pi over 4, 2 pi, it's right down the middle here. And the sign of that is the y coordinate. And if you recall, those are the radical 2 over 2s. Radical 2 over 2. And since we're in quadrant 2, we start with a negative cosine. So the sine of 3 pi over 4 is a positive radical 2 over 2. The sine of 225 degrees. Okay, this is 180 degrees. This is 270 degrees. So 225 is right smack in the middle. 225 degrees, that's my radical 2 over 2s again, only because they're in quadrant 3, they're both negative, and so the sign is negative radical 2 over 2. And then the cosine of 11 pi over 6, well, I know this is 12 pi over 6, because that's 2 pi. So 11 pi over 6 is going to be right here, and that is my pi over 6 reference angle. And so I know that one is the same in quadrant 1. So it's going to be square root of 3 over 2, 1/2. And which one's negative? The negative is on the 1/2. And so the cosine is positive radical 3 over 2. Okay, I hope this makes sense. And I have some flippers that can help you with these as well. So I'm going to stop this video and continue in the next video.